Okay, very good. Let's see what part 2 is. Part 2. The book briefly glows with a golden light, and you notice new content appearing on the previously blank pages just after the answer you entered. It seems my function becomes rather impractical when the input values get too large. The resulting numbers grow far too long. But what if I use only the last 5 remainders instead? Let's see how that works in practice. For example, NE275 equals 34213 because... Oh, we're truncating it to just 5 numbers now. Okay. Just like before, it's worth practicing with the new list of parameters. Your formula stays the same, and again, to check the calculations, simply find the highest number produced that way. All right, so we have a couple of examples. Yeah, and now is when the exponents get really, really big, so doing it in a loop no longer becomes practical, blah, 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 which means we're going to use our power mod code that we have over here. So, well, let's first do it. I guess it's a different function, right? It's no longer any. If we're going to use the same file to do it, we should create a truncated version of any. Trunk any. It's the same signature though, right? And then we'll just, for now, we'll just put 0. So what we'll do, I guess, is just, well, okay. So how would we do it with the power mod function? Because that's obviously the way we would have to approach it. With these size numbers, this is what we have to do. This is interesting. Oh, because is this the same input as last time? Let's see. I'll just save this really quickly. It's not used, that's fine. So this is, we have now 2 different test 2s. So let's call this test 2 1. Oops. I meant to say cat into test 2 1. Like that, diff test 1 and test 2 1. Oh, they are different. Oh, okay, yeah. I see now. All right. That's fine. And then into test 2, we'll have the bigger one. And what we'll do is we will use the power mod. The key is we only need the last 5. So we can jump forward. Like here, well, this is just 3, so that's all we're going to have. It's still 954, right? That was the answer here. But here, for y is 14, we don't need the first 9. So we can jump to the 9th one using the power mod function and then loop over the last 5 using the same code we have from before. So let's pull that in. Use AOC lib power mod, right? And it gives us a little function signature here, which is nice. I like the this new version of the LSP. So what we can do is trunc any. What we'll say is if the exponent is greater than 5, right? Because we only need the last 5. Then we can just go directly to it. We can say, instead of starting the score at 1, actually we just said here, right? If it lets mut score is equal to, if the exponent is greater than 5, we'll call power mod on nx minus 5, mmod, else 1, right? We expected 4 arguments, found 3. What's the 4th argument? Start, base, exponent. Oh, start. Okay. I guess I did that in case we wanted to start with some other number. Okay, anyway, that's good. So this way, now we can jump straight to the fifth to the last one, and then we can just use the same exact code here and get them all. Right? And if it's less than 5, or less than or equal to 5, then we just use these. That should be all we need to do. Let's test. Oh, they don't give you the individual answers here. Okay, but we do have the individual answers here, so we can at least test this one here, right? We can say test trunk any one. We'll do a couple of them. Well, these are all zeros. Interesting. That's a good edge case that I hadn't considered. So let's do this first one here, any 5, 6, 15. And that's equal to this big number here. All right, and this is trunk any 8, 8, 6, 16. Oops. Oh, I forgot to initialize the list here. We can do it here. Let list string new. Well, that didn't work. Oh, did I do the wrong one? I did. I meant 5, 6, 15. Well, at least we tested the edge condition. That worked. 5, 6, 15. Ooh. Okay. So it should be 105, 105, 10. So I'm guessing it goes 10, 5, 10, 5, 10, and we have an extra one in there. Oh, greater than 4. No? There's an extra one in here. Oh, you know what I forgot to do? Yeah. Greater than 5. That's right. I need to actually subtract exp. Oh, I have to set exp to 5. So now it's more annoying, right? Let rest is equal to exp minus 5. Exp minus equals 5. And then this is just the rest. Yeah, okay. That's what I got wrong. That was dumb. And then we already tested the 0 condition, but let's do it anyway. This should be 0. And it's 8, 6, 6, oops. 16. Trunk any 2. Okay. So that's tested that. Let's test these guys now. We have the input. Test part 2, right? So we should be able to set lines equals AOC lib read lines test 2 text. Entries is equal to, it's basically this code here, right? Right, and then we're going to say the max is this guy here. And the actual is going to be, oh, we have to calculate trunk now, right? Because it's different. It's a different function. And when it's a different function, this is what you have to do. Okay. So it's basically entries, iter, map, entry, trunk, calculate, try into. And then we're going to max unwrap. Okay. And that attempts to multiply with overflow. Oops. Whoopsies. Okay, what are we doing wrong then? Trunk any. Oh, you know what I'm never doing is resetting the score. Because that's what I actually would want to do. I don't know why we're doing this way. Let's just say score is equal to score times n mod. And we don't have to worry about that rem thing, score. Okay, now it works. And I should probably fix this one as well. Yeah, and now they all still work. And if I hit run, oh, you know what? We don't have part 2 yet. Okay, let's implement part 2 now. It's basically all of this, except we're going to be using the other input. Input 2. And this is part 2. And instead of calculate, it's trunk calculate. And hit run. Oh, I never got my second part. Okay. Yeah, this is one of the things about Everybody Codes, which makes it different to AOC. AOC, you use the same input for both parts. In Everybody Codes, there's 3 parts with 3 different sets of inputs. I keep forgetting that thing. Ooh, that was a long one. 100 lines. Okay. That's okay. We can handle 100 lines. Run. We can't handle 100 lines. What did I call it? Input 2.text. What did I do wrong? Oh. I'm in the wrong directory. Quest 1. How is the test working? Oh, I guess it was just finding them. All right. Well, we got a big answer. Let's see if it's right. Hey, Quack, yeah, you're crushing it. That's the right answer. 3 days, 13 hours, 29 minutes, 53 seconds. Oh, look at that. Now I'm 57th. I was 68th for the first one. I think it was 68.